Okay, so in topic 20, worksheet 1, that's where we're talking about compositions of functions. So let's look at number 1. So in number 1, we have, all right, so we have f of x is 6 minus 3x, and then g of x is negative 5x plus 2. All right, now you have to remember that this notation right here, this open circle means composition. And so the definition, so remember the definition, that's important to remember that. Remember when I read this as F composed with G at X means this. Okay, so when you're dealing with composition at open circle, don't think of this as multiplication. Multiplication is a closed circle. If it's open circle, it's composition. And by definition, F composed with G at X is defined to be this. F of G of X. So basically, you're going to find G of X first, and then whatever G of X is, you're going to put it into F. Okay? All right. So let's go to this one. So by using this definition here with this, by definition, this means F of G of 2. Okay? So now we go off to the side and we got to figure out what G of 2 is. So therefore, G of 2 equals, and make sure you go to the right function. So I got to go to my function G. So wherever you see the variable x, I substitute 2. So I get negative 5 times 2 plus 2. So that's negative 10 plus 2, which is negative 8. So that is just G of 2 now. So now this becomes f of negative 8. So now that's easy. I go to my function f, and where I see the variable x, I substitute negative 8. So this becomes 6 minus 3 times negative 8. So that's 6 plus 24, which is 30. All right. So therefore, your answer f composed with g at 2, f composed with g at 2 equals 30. Okay. So the answer for that one is 30. All right. Letter B, you want to find f composed with g at negative 3. So same thing, except now instead of substituting 2, you're going to be evaluating it at negative 3. But remember, by definition, this means f of g of negative 3. So f listed first, g is listed second. So this is going to be your inside function. So you're always going to do the inside function first. So kind of like cover your this part up with your finger and notice that this is this right here. Okay? All right. So then let's go up to the side and figure out what g of negative 3 is. So g of negative 3, I go to my function g, and I substitute negative 3 for x. So I get negative 5 times negative 3 plus 2. So that's 15 plus 2, which is 17. So this right here is 17. So now this becomes f of 17. Okay, so now I'm going to my function f, and which is here, and whatever wherever I see the variable x, I substitute 17. So I get 6 minus 3 times 17. So I get 6 minus, and then 3 times 17 gives us 51. And so 51 minus 6 will then give us a negative, 6 minus 51 will then give us a negative 45. And so therefore your answer, you're going to say f composed with g at negative 3 is equal to a negative 45. Okay, so that answer is negative 45. All right, now if we look at this one now, so this says f composed with g at x. All right, so let's look at C. All right, so C, this time we have f composed with g at x. So let me go ahead and write down the functions again. So f of x, remember, is 6 minus 3x, and then g of x is negative 5x plus 2. All right, so by definition, this means f of g of x. All right, so cover it up. This is your inside function. So now remember, in the previous one, you were evaluating at a particular number. All right, so when I evaluate a number, I got numbers. So you notice that my answer here was a real number. My answer here was a real number. Here, though, I'm not evaluating as a number. I'm evaluating at the variable x. So keep that in mind. So g of x is this. So in place of g of x, I'm going to substitute negative 5x plus 2. So this becomes f of negative 5x plus 2. And you had plenty of experience evaluating functions at a variable expression. So you just go to your function f, and where we see the variable x, you're going to substitute negative 5x plus 2. So this becomes 6 minus 3 times, and then you're substituting this, negative 5x plus 2. Okay, getting rid of the parentheses, you're going to distribute. Now remember, don't say 6 minus 3 first. Okay, you got to distribute that negative 3. You got to do multiplication before you do subtraction or addition. So this becomes 6. A negative 3 times a negative 5x is a positive 15x. A negative 3 times a positive 2 is a negative 6. And then notice the 6's cancel out. They add it to be 0. And so I just get 15x. And so therefore, f composed with g at x is 15x. So that's this one, 15x. Okay, D, now notice this was F composed with G, this is G composed with F. Okay, so now this one, we have G composed with F at X. So again, remember, cover that part up, so this is going to be your inside function. So this time, by definition, that is G of F of X. So remember your inside function. Okay, so F of X, remember, is 6 minus 3x. So this becomes G of 6 minus 3x, because that's what f of x is, right? So y'all agree that f of x is this right here, okay? Now, I got to find g of this now. So I go to my function g, and where we see the variable x, I substitute 6 minus 3x. So I get negative 5, in parentheses, 6 minus 3x, and then plus 2. See that 2 right here. And so now distribute the negative 5 through here. I get negative 30. Negative 5 times negative 3x is a positive 15x plus 2. And putting in descending order, I get 15x, negative 30, and 2 is a negative 28. And so therefore, your answer, you're going to say G composed with F at x is 15x minus 28. All right, so that one's that. So 15x minus 28. All right, let's look at number 2. In number 2, I want to say one thing. Notice I forgot to say show work. Obviously, some of those you had to show work. And so if you just put the answers and you submit that, I'm not going to take off any points for not showing work. But on the test, I will say show work. So keep that in mind. And so, because some of these you can't do in your head, obviously. See, you have to show some work there. Okay? All right. So just want you to be aware of that. All right. Number 2, you have f of x is 5x plus 1. And then g of x is 5 minus x. All right, and so you want to find each of the following. Okay, so in letter A, you have g composed with f at 3. So since I'm evaluating at a real number, we're going to end up with a real number as the answer. There won't be any variables in the answer. So by definition, though, this means g of f of 3. So if you cover that part up, this f of 3 is your inside function. So now I got to find out what f of 3 is. So now I'm going to, remember, these are two different functions, so make sure you use the function for number 2. So I go to my function f, which is here. So I got to find f of 3. So you go to your function f, which is here, and where we see the variable x, substitute 3. So it becomes 5 times 3 plus 1, so that's 15 plus 1, which is 16. So this becomes, so this right here is 16 now. So this becomes g of 16. And now we know how to do that. G of 16, I go to my function g, and where we see the variable x, I substitute 16. So it becomes 5 minus 16, which is negative 11. So the answer, you're going to say g composed with f at 3 is negative 11. So this right here is negative 11. All right, letter B. Now notice the difference between A and B is that A, I had G composed with F at 3, and then in letter B, I have F composed with G at 3. All right, so again, by definition, cover this up, so you know that's going to be your inside function. And so you get F of G of 3. So now I got to go and figure out what G of 3 is. So G of 3, I go to my function G, and I substitute 3. So I get 5 minus 3, which is 2. So G of 3 is 2. So this becomes 2 right here. So now I've got to find F of 2. So now I go to my function F, and wherever we see the variable x, I substitute 2. So this becomes 5 times 2 plus 1. So 10 plus 1, which is 11. So F composed with G at 3 is equal to 11. All right. Okay, now, so I want you to be aware of this. So many students seem to think that if G composed with F at a real number is negative 11, let's say, and then F composed with G at that same number should be an opposite. That's not true, because notice those are not opposites right here. So this is F composed with G, this is G composed with F. Those are not opposites. All right, so be careful. Don't assume that. Okay, let's do F composed with G at X. So now again, notice that when I evaluated this composition at a real number, I end up with a real number. When I evaluate at the variable x, I end up with a variable expression. Okay. So C, I have F composed with G at X. All right, so by definition, this means F of G of X. So F is listed first, G is listed second. So cover this part up, and that's your inside function. So G of X, though, remember, is this function 5 minus X. So it becomes F of 5 minus X. So now I'll go to my function F, which is 5x plus 1, and where we see the variable x, I'm going to substitute 5 minus x. So it becomes 5 times 5 minus x plus 1. And then distribute. I get 25 minus 5x plus 1 in descending order. This becomes a negative 5x plus 26. So F composed with G at x is negative 5x plus 26. Okay? All right, so that is this one. So negative 5x plus 26. All right, now number 3, you have a quadratic function and a linear. So let's look at that one. So this will be number 3. So number 3, we have all right, in number 3, we have f of x is equal to 4x squared plus 3, and g of x is 3x minus 2. All right, in letter A, you want to find g composed with f at negative 1. So remember, open circle composition. By definition, this means g of f of negative 1. We now know we got to do that inside first. So we got to find f of negative 1. Make sure you go to the correct function. You got to go to the function f. So wherever you see the variable x, I'm going to substitute negative 1. So you got 4 times, make sure you put that in parentheses, negative 1 squared plus 3. And remember, negative 1 times itself is a positive 1. 1 times 4 is 4. So I get 4 plus 3, which is 7. So f of negative 1 is 7. So I get g of 7 here. Now I'll go to my function g, and wherever we see the variable x, I substitute 7. So this becomes 3 times 7 minus 2. So that's 21 minus 2, which is a positive 19. So your answer, g composed with f at negative 1 equals 19. All right, B, you want to find f composed with g at x. F composed with g at x. So by definition, this means f of g of x, right? And so g of x. Now remember, when we evaluated when we did a composition at a number, we ended up with a real number. Okay, but notice that this is not a real number. That's the variable x. So my answer is going to be a variable expression. So g of x is 3x minus 2, so this becomes f of 3x minus 2. And now I'll go to my function f, and wherever we see the variable x, I'm going to substitute 3x minus 2. All right, so this is going to be a little bit more work now, because you'll be squaring this. So this becomes 4 times 3x minus 2 squared plus 3. Okay, now let's go up to the side and kind of figure out what that is. So 3x minus 2 times itself, right? And so 3x times 3x is 9x squared. The outer is a negative 6x, and so is the inner. So that's a negative 12x. A negative 2 times negative 2 is a positive 4. So that goes here. So I get 4 times 9x squared minus 12x plus 4, and then plus 3. So when I distribute, I get 4 times 9x squared is a 36x squared. 4 times a negative 12x is going to give me a negative 48x. And then 4 times 4 is a 16, and then plus 3. Combining like terms, I get 36x squared minus 48x plus 19. All right, so that's letter B. All right, so that's 19 here. And then over here, we get 36x squared minus 48x plus 19. All right, and finally C. So in part B, we found f composed with g at x. In letter C, we're finding g composed with f at x. So letter C, g composed with f at x. So again, by definition, this means g of f of x. So remember, f of x is this quadratic right here, so 4x squared plus 3. So that's going to go here. So now we're going to find g of 4x squared plus 3. And so g of x is this. I'm going to write out g of x. So g of x is 3x minus 2. So where we see the variable x, remember that's where you're going to substitute 4x plus 3. So this becomes 3 times 4x squared plus 3, and then subtract 2. Distributing, I get 12x squared. 3 times 3 is 9, minus 2. So I get 12x squared plus 7. Okay, so that's letter C. So 12x squared plus 7. All right, so again, keep in mind that it didn't show work, and some of you are not going to show the work, but on the test, I will ask you to do that. So make sure you know what work I'm looking for. Okay? All right, so that is the key to topic 20.